Hey Ramblers, this video covers chapter 3.1 in our textbook and deals with shortcuts to differentiation. Now, it's going to seem like a little bit of a review. We've already covered the power rule, and this video has a lot of the power rule in it. So we're going to kind of give a little more of a conceptual support to the constant multiple rule and to the sum and difference rule. Then we'll take some examples and look at those, and I'll ask that you interact with this video through Zaption. Okay, Ramblers, good luck with the practice on this. I hope it helps and supports your understanding of the power rule, and thanks for watching.
You may remember from pre-calculus that when we multiply a function times a constant, it stretches the function vertically. So for instance, in the graph on the left, we have y equals f of x. In the graph on the right, we have y equals 3f of x. So, not surprisingly, the graph on the right is going to be 3 times as high at each x. So, what does that mean for the derivative? Well, if the slope had been m, then the slope is going to have to be 3 times m in the stretched function. And that should make some sense, because as you recall, slope equals the change in the change in y over the change in x. Well, if those changes in y's are 3 times as big over here, then the slope of these is going to be 3 times delta y over delta x, which would mean that your slope is going to be 3 times as big. Which brings us to the constant multiple rule. So please get this in your notes. When you're taking the derivative of a function and there's a constant multiple in front, like c, I can in effect pull that constant multiple out. Let's take a look at that. Suppose we had the derivative of x squared. Now we know from the power rule that that's just 2x. But now let's put a constant in front of it. So now we're taking the derivative of 3x squared. Now, we've learned from the power rule, the shortcut. But let's think of it a little differently. Now we're going to say that that's the same as 3 times the derivative of x squared. So that's going to be 3 times 2x, which is 6x. Okay, it's not a big deal, but it's another way of thinking about it. And as we get to more complicated functions, maybe it's good to have been introduced to it with something simple like the power rule. Okay, let's take a look then at the sum and difference rule. Okay, this rule is another one that we've kind of already been exposed to in the last chapter as we got a look at the power rule. But it essentially says this: if you're taking the derivative of two functions, then their derivative is just the sum or difference of each derivative. Okay, what does that mean? Well, suppose we're taking the derivative of 3x squared plus 5x, then that's just going to equal the derivative of the first one, 3x squared, plus the derivative of 5x. Now, we've already seen this last chapter, so it's not a big surprise, but we can use the power rule, kind of combined with the constant multiple rule, to get 6x, and then we will get the derivative of the second term and get plus 5. Alright, so it's, again, not very difficult, but when we get into more complicated functions, it might help to have learned this with easier ones like this. Okay, let's try some practice on the power rule just to make sure you've got it squared away. Okay, we're going to take this chance to practice taking some derivatives. So let's start off with something pretty familiar. Let's find the derivative of 5x squared plus 3x plus 2. Now you can see this is just a combination of the common multiple rule, the power rule, and the sum rule. So we're just going to take the first term is going to be 5 times the derivative of x squared which is going to be 5 times 2x, or just 10x. Honestly, I think it's just easy of thinking that as the exponent times the coefficient. But then it's going to be plus 3, and then that last term is a constant, so the derivative is 0. All right, let's practice another one. Let's take the derivative of the square root of 3, x to the 7th, minus x to the 5th over 5, plus pi. Now let's take a minute and solve this one, and answer it on Zaption. Okay, this one we're going to get 7 times the square root of 3, x to the 6th, that's just the constant multiple together with the power rule, minus x to the 4th, because the 5 that's in the exponent is going to come out in front and end up canceling with the x in the denominator. And then since pi is a constant, its derivative is 0. So we just get 7 root 3 x to the 6th minus x to the 4th. Okay, how about this one? 5 root x minus 10 over x squared plus 1 over 2 root x. Solve that on Zaption and continue for the answer. The first thing I would do is rewrite this whole expression using negative exponents and fractional exponents. In other words, get rid of the radicals and get exponents out of the denominator. Then I would use the power rule and constant multiple rule to get 5 halves x to the negative 1/2 plus 20x to the negative 3. Be careful, when you have a negative exponent and you reduce it by negative 1, it actually, the magnitude gets bigger. And then finally, minus 1/4 x to the negative 3/2. Now, if you want to rewrite this, you get 5 over 2 root x plus 20 over x cubed minus 1 over 4 times the square root of x, times the square root of x cubed. Okay, Ramblers, that's about it on this video. Thanks for watching, and I hope this helped.